myself Dr. Preeti Jagwani. I am from Department of Computer Science, Aryabhat College, University of Delhi. So, presently we are going through our series of advanced data structures and algorithms, and in this series today's topic is list and iterators, ADTs. So, when I say ADT, that means I am here mentioning about the abstract data types. So, list and iterators as abstract data type, this is what we are going to study further. So, when we talk about any abstract data type, first of all we need to understand what that abstract data type is. So, let us begin with the simple most definition of data structure. So, when we talk about data structure, it is nothing but a technique of organizing the data so that your data can be utilized efficiently. And this technique of organizing the data inside the any storage space, or you can say memory. Now, when we organize this data inside the memory, we obviously need to have a look onto it, have want to perform some operations onto that particular organization of data or on that data. So, basically there are two ways of viewing any data structure. One is going to be an abstract view, an abstract model, a mathematical model or logical model. And the second point of view through which we can look into any data structure is about the implementation. So, let us first look about let us have a look primarily at what, when we talk about the mathematical, logical or abstract model, what is that? So, when we organize the data in in any format, that requires some standard conventions, some protocols are or we can say some rules, and these rules need to be modeled, and these rules comes under the logical or abstract model. So, basically we can say the constraints, the protocols or rules which are required for modeling that data structure, they comes under the abstract model or the logical model. We will talk more about it. While if we say the implementation point of view, the implementation point of view says how to implement these rules which we were talking about in our first part. So, how to implement those rules in any of the programming language. So, when we talk about any abstract data type, so till this point I told you what is data structure, and there are we can say two views to look into a data structure. One is an abstract view, another one we can say is an implementation view. So, when we talk about abstract view in detail, we encounter a term which is known as abstract data type, and this abstract data type ADT is an abstraction of the data structure that provides only the interface to which the data structure must adhere. This interface will not give any specific details about how that data structure or how any operation, how something could be implemented, or in which particular programming language I am talking about. So, abstract data type, when I talk about, it is kind of a representation of a data structure in an abstract manner. Abstract manner in the sense it is only going to provide the interface to which your data structure is going to adhere. So, these abstract data types are the entities that are the definitions of data and operations, but they do not have implementation details. So, let us take an example first, and then we will talk about we will talk about later details. So, for example, let me talk about the languages C and C++. In C, language C, the data structure is implemented using structure. So, when I am talking about the structure, structure as in struct of your C language, that is implemented with the help of a structure, while in C++ if we talk about, we implement those data structures with the help of objects and classes. So, there are two different kind of implementation views, but when we talk about the term struct or structure, the structure is implemented in C with the help of struct and its members and then their references and so on and so forth. But when we want to implement the similar thing or the similar concept in C++, we use objects and classes. So, basically what is happening here? So, this structure is actually an abstract data type that is going to provide the definition of data and operations. So, the definition would be, for example, we are going to take a student as in structure. So, that student will have a name, then it will have a roll number, then it will have some percentage or maximum marks, and we can get some attribute, we can set some attributes onto it. So, there are some operations and there are some definitions which are attached to this particular structure. In C, when we are going to implement this concept, we use the term struct, and in C++, when we are going to use this, when we are going to implement this very thing, we will be using the concept of objects and classes. So, basically the data which we are storing and the operation that can be performed on data are described by the abstract model, but we do not know the implementation details. Implementation details are varying for both the languages. So, implementation details is actually the thing which is looked upon by the implementation view, and only the kind of, we can say, the interfaces is something, or the operations which we are going to define on that particular struct are something which are going to be looked upon by the mathematical model. So, there is a mathematical or abstract model, and another model is about the implementation details. Now, the question comes up that why are we not having the implementation details along with the mathematical model? Because this implementation details will differ for every programming language, and every different programming languages have different implementation strategies, as I have told you. Also, if we talk about a particular data type, let us say list. Now, that list can be implemented using a linked list, or it can be implemented using an array, or it can be implemented using a dynamic array. If I talk about the data type Q, that data type Q can be an array based queue. That means we will implement that with the help of an array, or we can implement that with the help of a linked list. All these implementations we have seen in our course of data structure. So, linked list based queues are available, then we have array based queues, and then we can always combine two stacks and implement a queue. So, a queue can be implemented in different ways. One is linked list based queues, another one is array based queues, or it could be an stack based queues. On the similar lines, if we talk about a map, so a map, it could be a hash map, it could be a hash table, it could be a tree map. So, various ways to implement a map. So, that is why here implementation details are actually not mixed with your abstract model. Abstract model defines the data, defines the operation to be done on that particular data type, but it is not going to give you any details about the implementation. So, for example, list. So, list is going to be we can say a sequence of elements, and then there will be some operations. Those are kind of common operations, could be insert, update or delete. But how to implement that update or delete, that means if you are going with the linked list based implementation, then it will be a different strategy in order to insert or delete the new nodes or the new elements. If it is in the form of a dynamic array, then this strategy is going to be different. So, any data structure can be viewed in two different ways. One is the mathematical or the abstract way, and another way is nothing but your implementation side. As I have told you, I have given you 3-4 examples. One is of a list, another one is of a queue, and third one was map. So based on these, based on this particular background, we have many abstract data type which are required to be implemented, or which are required to be studied for various purposes, for various applications. One of these data structures, or one of these data types is basically as known as vectors. And vectors is what which we are going to start in in detail in this particular topic as one of the subtopics. So we will be finishing vectors first, and then we will be moving on to another data structure. So when we talk about the term vector, now one disclaimer here, I will be taking vectors as it is as this is implemented in C++. So I will be going into the C++ details of this vector. Now vector basically in C++ is implemented as a class template, or I can say this vector is actually kind of a component of STD, and I am sure you all are aware of what is this STD. So STD vector in C++ is it's a class template that contains the vector container and its member function. So basically vector is contained inside this STD as a class template in the form of a container, and within that container it is also having its member function. It is defined inside the vector header file, and there are various member functions of this STD vector class which provide functionality to vector containers. Now what kind of functionality I am talking about? This functionality could be insertion of the elements maybe in the middle, maybe in the kind of starting, or maybe in the end, or something of that sort, removing those elements and kinds of erasing those elements, or maybe kind of we can say updating those elements, and so on and so forth. So there will be various member functions which we will be looking into detail. With all the member functions are the functions of this STD vector class, which provides various functionalities to these vector containers, and these member functions are defined, or this particular actually class is defined inside the vector header file. So there is a vector header file, and within that vector header file we have a container along with its member functions also. Now when we talk about the term vector, we understood that basically it is kind of an you can say it's a list, or it could be, you can call this as a array. Now how this is different from your traditional array? So one thing, or one particular keyword which is going to differentiate the term vector from standard array is about vectors being dynamic. So these vectors are automatically capable of automatically sizing themselves dynamically. What does it mean? Let us try to understand. So vectors automatically resize when we add or remove the element. So obviously when we are adding, the size of the vector will grow, and when we are removing the elements, the size of the vector will shrink. So this is the flexibility, which is one of the main reasons that why vectors are preferred over traditional arrays, because in traditional arrays, if you want to kind of resize that array, that in I cannot say that they cannot it cannot be done. Of course it can be done, but there are very different ways. So for example, if you want to resize the array, you need to take if you want to increase the size of the array in traditional situations, so a larger array has to be taken, then all the elements which are available in the array are to be copied onto that larger array, or that kind of memory allocation is also done with the help of new and free keywords are there to release the memory. So sizing the traditional array in the runtime or dynamically is not very easy, or it is not very straightforward. but vectors can automatically resize when we add or remove the elements. So, this is one of the very important kind of line of difference between the traditional array and the vectors. Next, if we talk about the characteristics, further characteristics of your vector, it comes to insertion and deletion. So, insertion when of a particular element is usually typically done at the end of the vector, and we have we are aware of the end index of the vector. So, then insertion at end will become a constant time operation. So, insertion in a constant time is also kind of something which a programmer would like to have. However, if we talk about insertion or deletion elements at the beginning or maybe in the middle of the vector, that is going to take linear time, because due to we need to shift the elements. So, for example, insertion is done at the middle, then right half of the element are to be shifted, or for example, the middle element is deleted, then that right half of the elements are to be shifted left side. But this shifting process will take linear time. But if we actually want to insert or delete at the end, then it is going to take a constant time. So, constant time operation, and if insertion and deletion in middle is to be done or at the beginning is to be done, it is going to be a linear time operation. So, basically here is a kind of improvement of efficiency in terms of time complexity if we talk about insertion and deletion in comparison to what it was there in traditional arrays and what it is here in vectors. So, one is the vector is able to dynamically resize itself, then insertion and deletion are actually have become cheaper operations. Then the third characteristics which we talk about is the efficient access. So, since vector elements are stored in continuous memory locations as that of arrays, we can access elements in a constant time using their index, which is a property similar to arrays. So, the facility of using the index in order to access the elements efficiently, which is available in traditional arrays, is also available here in vectors. Along with that, dynamic resizing is available, plus efficient or cheaper operations of insertion and deletion are also available. So, these are the we can say key characteristics in which because of which we actually want to prefer the vector over any traditional array. Now, in terms of C++, how we are going to declare the vector, the syntax is available on the screen. So, this will be std, then a scope resolution operator, vector is the name of the class, then there will be the data type. That means for which particular we can say data type you need to form that vector. So, that vector is going to be of integer, or that vector is going to be for characters, or that vector is going to be for float or something different than that. So, std scope resolution operator, which is nothing but the double colon, vector the name of the class, the data type within angle brackets, and then we have the vector name. So, the vector name is the name of the vector which you want to declare. So, for example, std scope resolution operator, then vector int, and vector name is let us say v1, then this v1 will be a vector of the integer data type. But when we talk about the term template, we can supply any data type here if we are using the templates here. Now, in case of default initialization and default creation, how are we going to do that? When we talk about default initialization, that means an empty vector is going to be created, and then that vector can be filled later on in the program. So, here it is going to be vector, then within the bracket I have written t. Now, why I have written t? This is because of a template, and then the name of the vector v1. Now, here I have not used any scope resolution operator and std, because I am assuming that std I am going to kind of include within my C++ program. So, there is no need to pre-qualify every time I am using this vector class. There is no need to pre-qualify that vector class with the help of std and scope resolution operator. So, if we want to create an empty vector, we can create it using this particular very declaration, and then this vector can be filled later on in the program. Now, sometimes it is a requirement that we need to initialize our vector. We need to create a vector, initialize that with a particular size and some default value. So, that also is a possibility with the syntax which is given on the screen. So, the syntax will be vector, and then within the angle bracket the data type. Here I have written t as in template for that, then vector name, for example v1, and the two parameters size and value. In the earlier example or in the earlier declaration, there was no parameter inside this vector name, but here we have two parameters. One is a size. A size we can say that is a vector of that particular specific size will be created, and then it will be initialized with the given value which we have passed after the parameter of size. So, two parameters, one size which will determine the size of the vector, and the value which is going to be filled into that particular vector as a default value. So, apart from this, there can be various ways of declaration of vectors. Speaking in very detail, there are 8 ways of declaration of vectors which are available. Specifically, if we talk about C++, we will be looking into those 8 ways of a declaration of vectors. Here in this particular lecture, what we have learned is we started from data structure, and we have taken a very small kind of a very simple definition of data structure, and we have seen that this data structure can be modeled with the help of either the abstract view or the implementation specific view. Then that abstract views took us into the concept of abstract data type. Abstract data type, we tried to understand what is that, and then we started with one of the abstract data types which is vector. So, vector here is basically we are going to take this vector by point of view of C++ language, and we will be looking into the syntax of all the basic operations of vectors from C++ syntax point of view. In our upcoming lectures, we will be looking into ways of initialization. I have told you there are so many ways of initialization, to be precise 8, and then we will be also looking into various basic operations, that how to insert the elements, how to delete the elements, or how we can kind of access the elements, and other utilities of these vectors. So, this is all from my side for this particular lecture. Here is a list of references which is being used for the preparation of lecture. I hope you have enjoyed this one. More to be continued in this topic of vectors, but that in the next lecture. I will see you in the next one. Till then, take care. Goodbye.